Hi guys, this is Ms. Miner, and this is lesson 12C, and we're going to be talking about dilating images on a graph. And that a dilated image creates what's called a similar figure or a similar shape. Okay, so let's jump right into it. Remember, a dilation is going to resize our object. Here we go again with my pen. All right. A dilation is a resize of an object. I'm going to either make it bigger or I'm going to make it smaller. I can dial something up or I can dial it down. Okay. So here's our object. And the way that we dilate is the first thing that we need to do is we need to know that there's usually what's called a center of dilation. And it's the point that we're dilating from. So we could dilate from a point way out here and blow something up from this point, right? We could use any point really on this graph to dilate from, and it's going to kind of push that image. It's going to make it bigger or smaller at an equal distance from wherever I'm dilating from. But in this class, for our purposes, we're going to start with just the basics. And so our center of dilation, it's the point we're dilating from. And we are only going to use the origin. Our center of dilation is going to be the origin, or 0, 0. So that is the only place we are going to dilate from in this class. So our center of dilation is going to be here, and everything is going to be resized from that point moving out. So we'll kind of see how that works. Okay, the other vocabulary piece that you need to know is, what is a scale factor? And we've talked about scale just a little bit as we've been graphing, but a scale factor tells us how big or how small we are going to make our object. It tells us how much we're going to dilate our object, either how much bigger or how much smaller. If I have a really big scale factor like 10, then my object is going to get 10 times bigger. If I have a really small scale factor, like a fraction, like 1/4, right, then my object is going to be 1/4 the size that it originally was. So that's kind of how a scale factor works. It tells us how big or how small our object is getting. Okay, so let's start with a basic scale factor. A scale factor of 1 would be the exact same size. The original object and the dilated object would be the exact same size. So a scale factor of 1 is equal. They're the same size. But let's just use a basic scale factor of 2 to start out with. Let's say my scale factor is 2. Well, this means my object, my triangle here, has to be 2 times the size that it was originally. So there's an easy way to do it. Let's first identify where each of our points is currently located. X is currently located at -3, +2. Left 3, up 2. Right? And Y is currently located at -3, 0. Z is currently located at +2, 0. I want to make this object 2 times bigger. The scale factor is 2, so I want to make it 2 times bigger. What I need to do is I need to go through and I need to multiply each of these coordinate pairs by 2. So X prime is going to be at -6. -3 times 2 is -6. 2, 4. 2 times 2 is 4. Y prime is going to be at -6, 0. Z prime is going to be at 4, 0. 2 times 2 is 0, 2 times 2 is 4. 0 times 2 is still 0. So all I did was I went through and I multiplied each of those coordinates by 2, and now I am going to regraph it. So x is now at -6. -6, +4. I've got to go up 4. That is going to be x prime. And if you'll notice, this was at 3, right? It was a length of 3, and now it is a length of 6. Its length has doubled in size. So you can kind of already start to see that we are doubling the size of this shape. So y was at -3, now it's at -6. That's going to be y prime. And z was at +2, now it's a +4, z prime. And then all I have to do is go through and reconnect my points, and I have made this shape 2 times bigger. Now let's prove to ourselves that we've actually dilated it 2 times bigger. The original length of side y, z was 1, 2, 3, 4, 5, right? Now the length of side y prime, z prime is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 2 times bigger, twice as big, right? Same with this side. Over here, we can check any of those sides because a dilation is proportional, right? The word proportional, the side lengths, right, are related in size back to whatever my scale factor is. I had to think about how I wanted to say that, right? My scale factor is 2 times bigger, so each side, right, should be times by 2. So if this side length was 2, this side length is proportional to that by an amount of 2. It is twice as big. Okay, I hope that kind of makes sense. These are what we call similar figures. They're similar in that they are the same exact shape. And in similar figures, the side lengths are also proportional to each other. So this side length is 2, this side length is 4, and we could see exactly what the scale factor is based on that proportion, right? They're proportional by the amount of the scale factor. Okay, so hopefully that helps you kind of see how dilations work. Okay, we're going to back it up just a little bit, back to our original shape that we had here. Okay, so here we are again. If you didn't get those definitions that I had written there before, then scoot to the video back just a little bit. Make sure you have those definitions written in your notes. Okay, so let's restart where we were. This time, let's make this image smaller, right? Let's dial it down, and let's make this half of its original size. So we're going to start out, x is at -3, 2. Y is at -3, 0. And z is at +2, 0. I need to times all of these numbers here by 1/2. So x prime is going to be at -1.5, half of 3, right? And 2 becomes 1 because half of 2 is 1. Y prime is going to be at -1.5 or 1.5, right? And 0. And z prime is going to be at 1, 0. So all I did was I went through and I multiplied all of those coordinate pairs by 1/2. And you can do that right in your calculator. Okay, then what I want to do is regraph this object. I need to go to -1.5. So I need to go 1, and then I need to go halfway through the next box, right? But then I also need to go up 1. So halfway through the next box, but up 1, that's going to be my x prime. And then y prime is going to be halfway through that box as well. That's going to be y prime. prime, and z prime is going to be at 1, 0. There's z prime. And then I reconnect my dots. And there's my shape. And we can see, again, we can check our work and see, hey, this side length is a 1. This side length is a 2. My new shape just got half of its original size. So we can see, and we can see those side lengths are proportional, right? They're proportional 1 to 2, just like my scale factor, okay? All right, so I can make my image bigger. I can make my image smaller. My scale factor literally tells me how many times bigger or smaller to make my image. Okay. How big or small was this dilated? Let's write a rule. So I want to figure out what is the scale factor, right? I know this was a dilation. Normally when we have scale factor, we use the variable k to represent our scale factor. So I can say scale factor, maybe this is a good note to have, is k. Scale factor is k. If you see k equals something, that's our scale factor. So sometimes we even refer to it as the k factor. You'll hear me kind of say that in class sometimes. So scale factor is k. So this, I want to write the rule. I want to figure out how much was this dilated by. There's a couple of different ways that I can do that. I can first just pick 2 points. It started right here. Here's A, right? Point A. That's where it started. This is the pre-image. This is the image back here. So it started with this small one in the middle. And then it became A prime up here. I'm going to mark that one blue. Okay. And I can write the coordinates for both of those points. So A was at -1, +2. That's where it's located currently, or before, in the pre-image. Then A prime was -2, 1, 2, 3, 4, -2, 4. So if I have the coordinates, remember what I did to get from A to A prime was I multiplied by the k factor. But I don't know what the k factor is. So I can divide in order to get it, right? I can take where it is now and divide by where it was in order to figure out my scale factor. So A prime divided by A, where it is now, divided by where it started, gives me my scale factor. This is 2 times bigger now than it was when it started. The other way I could find out the scale factor is I could take a look at the side length. Pick a side length that's easy to find, right? This side length here is an amount of 3, right? It's 3 units long. Well, take a look at this side length over here. 1, 2, 3, 4, 5, 6. That side length is 6. How many times bigger is the image than the pre-image? 2 times as big. So I could also take the side lengths and divide to find the scale factor. And that's very important for our next lesson, that these side lengths we can figure out are proportional to our scale factor. And so I can use coordinates to get me there, or I can use a side length to help me figure out what my scale factor was. And so this image has been dilated by a scale factor, a k factor of 2. And that's my rule. All right, so how can I figure out just from coordinates? What if I don't have a graph, right? What would the new coordinates be? Well, remember, all I have to do is if I have a scale factor, then I just go through and I multiply all of these coordinates by the scale factor. So I can put it right in my calculator. I can say -2 times 1.5 gives me -3. So T prime. Oh, come on, pen. T prime is going to be at -3, negative 3, because 2 times 1.5 gives me 3. And then I can do the same thing for each of these. U prime, I would take negative 3 and times it by 1.5, and I would get negative 4.5. And then anything times 0 is just 0, so U prime. So go through, you can dilate the last couple of these on your own if you want to pause the video. If you pause the video and you're coming back, then V prime would be at 1.5 and 3, and W prime would be at 4.5, 0. So there we go. Remember, we're just taking our scale factor and timesing it by the coordinates. If I'm not on a graph, if I just have the coordinates, then there we go. We just go through, we times all of the coordinates by the scale factor. What if I have the coordinates for the pre-image and the image, or let's say the original image and its dilation? Well, then remember, all I have to do is go through and divide the image divided by the pre-image. So scale factor, let's just maybe even put this in our notes. K is equal to the image divided by the pre-image. Or you can put it however you want. We could say the dilation, we take the dilation and divide it by the original. I prefer image to pre-image, so let's put that in there. K is equal to image divided by pre-image, because that is most likely how you will see it in math. You'll see image divided by pre-image. So you take your image, negative 4.5, and divide it by your pre-image, and that's going to give you your scale factor. Negative 4.5 divided by 9 is equal to negative 1/2. Or we could choose something easy. Look at these right here, 6 and 3, right? If this is really hard for me to figure out, choose a coordinate that is easy to figure out and then do the same thing. 3 over 6 is obviously equal to 1/2. So there's my scale factor. So choose some numbers from your coordinates that are easy to kind of figure out what's happening there. All right. So we want to make sure we have that in our notes. Let's see how much farther we have to go here. Oh, okay. On your homework today, you're going to have a combination of all of the different kinds of transformations that we've talked about to this point. So use your notes to help you figure out, hey, if I have coordinates, right, then we can use our coordinate rules to help us figure out, this one's a rotation. What will be the coordinates of the prime points after we've rotated this? Is this a translation? Is this a reflection? Is it a rotation? It could be a dilation. So we have to know how to figure out what kind of transformation has taken place. So use your notes to help you figure out those things. All right, that's as far as we need to go for today. And if you have any questions about dilations, make sure you're talking to me or Mrs. Zeider so that we can help you out with any questions that you need. Good luck, guys.